graphing quadratic relations of the form y equals x squared plus bx plus c. So sometimes this is called speed graphing. So we are graphing a quadratic relation without having to create a table of values. So we can graph quadratic relations or parabolas quickly using a procedure called varies. And varies is just an acronym that represents the different things that you're going to look for when you are trying to come up with your quick graph. So step number one would be to plot or find or plot the y-intercept, which is the y from the word varies. So we're going to start with a quadratic relation in standard form. Now a parabola can be written in three different ways. It can be written in standard form, which is y equals x squared ax squared plus bx plus c. And when it's written in standard form, the end number c is the y-intercept. So each version of the quadratic relation will tell you different information about your quadratic or your parabola. So again, you're going to learn more about this in grade 11, but this is an introduction. So this last number c is going to be your y-intercept, so whatever that number happens to be. If there is no constant term in your quadratic equation or quadratic formula, then you are going to have a y-intercept of 0. So remember that the y-intercept is the point where the graph crosses the y-axis. And it has a coordinate of 0 and then y, where y is that number where it intersects. So for example, in the equation y equals x squared minus 6x plus 5, the y-intercept would be a positive 5. So we would say it has a y-intercept at the coordinate 0, 5. In our previous unit, we learned how to go from a trinomial, so x squared plus bx plus c, to a factored form, so to two binomials multiplied together. And this is important because when we are thinking about the factored form of a quadratic relation, it's going to look like this. Y equals a, x minus r, x minus s. Now in our questions, we are going to deal with an a value that's equal to 1, just like we did when we were factoring trinomials in our previous unit. So keep that in mind as well. So if we just have even here in our first equation in standard form, our a is going to be 1 for these ones. In grade 11, you'll get to some more complicated ones, but for our work in this year, we're going to just focus when there is no a value, or maybe just the a value is a negative number, or it's something that we can common factor out quickly. So sometimes you might also see this written, your standard form when the a is 1 as y equals x squared plus bx plus c, which is how it's written up in the title. And then for the factored form, if our a value is 1, it'll just be x minus r, x minus s. So keep that in mind as well. So these are the generic versions, and these are the red ones are the versions where our a value is equal to 1. So what does that mean though? So we know that we can factor a trinomial so that it looks like two brackets being multiplied together. So what do these r and these s values mean? Well, the r and the s numbers are the x-intercepts, or the zeros. Remember, those two words are interchangeable. They're the points where the graph crosses the x-axis, and they have a coordinate of x0, where x is wherever it crosses that x-axis. Remember, we can have 1 0, 2 zeros, or no zeros, depending on where the parabola is drawn on that Cartesian plane. So how do we find those zeros? Well, once you have it in factored form, we would set each of these equal to 0, which is why it's A. See that? That's why it's called zeros. And then we're going to solve for those x. So sometimes you'll have to do it twice, and sometimes you'll only have to do it once. So for y equals x squared minus 6x plus 5, we want to start by factoring that equation. So we're looking for, I'm just going to do my calculation up here. So I have y equals x squared minus 6x plus 5. So I'm looking for two numbers that multiply to give me positive 5, and those same two numbers need to add to give me negative 6. Now, in order for me to have a positive number being multiplied, they either have to be both negatives or both positives. They can't both be positives because then I wouldn't have a negative number. So I know that they both have to be negatives. And what two numbers multiply to give me 5? Well, that's 1 and 5. But because they have to be negative, I'm going to have negative 1 and negative 5. Because two negatives make a positive when I multiply them together, and negative 1 take away 5, or negative 1 plus negative 5 is negative 6. So those are my factors. So I'm going to have x minus 1 and x minus 5. So this equation from standard form to factored form would look like y equals x minus 1, x minus 5. And we're going to now figure out what the x-intercepts are. So we're going to set each of these equations equal to 0. So I'm going to have x minus 1 is equal to 0. And then I'm going to isolate for my x. So these are my solving equation skills. So remember, the opposite of subtracting 1 is adding 1 to both sides. Minus 1 plus 1 is 0, and 0 plus 1 is 1. So I have one x-intercept at 1, 0. So that's going to be one of mine, because remember, the x-intercepts always have the number and then the 0. So 1, 0 is one of them. And then I'm going to do the same thing with my second bracket. I'm going to write my bracket, and I'm going to set it equal to 0. And I'm going to isolate for my letter x. So the opposite of subtracting 5 is adding 5 to both sides. Negative 5 plus 5 is 0, and 0 plus 5 is 5. So I have my other x-intercept at the coordinate 5, 0. So I've identified my y-intercept, I've identified my x-intercepts. Now the more you do this, the easier it's going to get. You'll also notice that when I have it in factored form, my x-intercepts are the same numbers but different signs. So eventually you'll get to a point where you won't have to do all of this work. You'll be able to say, okay, x minus 1, that means I have 1, 0 at positive 1, 0. X minus 5, that means I have 1, 0 at 5, 0. So whatever these brackets happen to be, you're just going to switch the sign to find the x-intercepts. So that's nice and quick and easy way to do that. So we found our R and our S. So that's R and S because this is how we write it in the generic form. And you'll notice that this is the generic form of factored form. And so we use the R and the S. You'll see that again next year. So that's the R and the S from the word varies. Now we're going to find the A, which is the axis of symmetry. We know that the axis of symmetry goes directly through the middle of our parabola. So the great thing about finding your zeros or your x-intercept is that it'll help you find that middle point of your parabola. So the zeros of your parabola are equal distance from the vertex. So that means that we can use the x-intercepts in order to find the midpoint or that vertex. So we're going to use the x-intercepts to find the midpoint or the axis of symmetry, or we can find the x value of the vertex. All of those are going to be the same thing. So the way we do that is we use a formula which is x equals r plus s divided by 2. So we're going to add our x-intercepts together, whatever they happen to be from that first step, and we're going to divide them by 2. So for our question, our x-intercepts were 1 and 5. So my equation of the axis of symmetry will be x equals 1 plus 5 divided by 2. 1 plus 5 is 6, and 6 divided by 2 is 3. So the equation of my axis of symmetry is x equals 3, which means the x value of my vertex is 3. So that's important to know as well. So the last thing that we're going to find is our v, which is our vertex. So we know that the axis of symmetry, the x value in our equation is the same as the x value in our vertex. So we're going to use that information to find the y value, or to find the second part of my vertex. So the vertex is in the form xy, where this x is from your axis of symmetry, and we have to use that information to find our y. So we're going to substitute the value of x into my original equation, and we're going to find the value of y. And the vertex is located again at that point, as I said, xy. So we're going to take a look at our equation, y equals x squared minus 6x plus 5. And we know that our x value of the vertex is 3, because that's our axis of symmetry that we found. So now we're going to take that value of 3, and we're going to put it in place of our x squared and our x. So our y is going to be 3 squared minus 6 times 3 plus 5. 3 squared is 9, minus 6 times 3 is minus 18 plus 5. Y equals 9, take away 18 is negative 9, and negative 9 plus 5 is 4. Negative 4 though. So now we have a vertex at the coordinate 3, negative 4. So we're going to take all the information and plot it in our graph. So we said that our y-intercept was 5. So it's right there. We said that we have an x-intercept at positive 1 and positive 5. And we have a vertex at 3 and negative 4. I also know that because my parabola is symmetrical, that I would have another point right there. So using that concept of reflection points is very helpful. And then I'm just going to connect these in a nice smooth line. I draw arrows on either side to show that my parabola goes forever in both directions, and that is how we can use that information about the parts of the quadratic to quickly sketch a graph without having to do a table of values. I promise you it will get quicker the more that you do it. Okay, so let's go through a few different examples. One thing that I wanted to talk about is, so we use the points to draw the parabola. And one thing is the step pattern. So the step pattern you're going to learn about in grade 11 more, but the step pattern of a normal equation. So for our equations, when the a is equal to 1, the step pattern is 1, 3, 5. So what does that mean? Well, that means from our vertex, we go over 1, and we go up 1, and that gets our next point on that graph. So there's my second point. From that point, I go over 1, and this time I'm going to go up 3, and there's my next point on my graph. And then from there, I go over 1 unit, and then I would go up 5, and there's my next point as well. So some people, when they're sketching a graph, they will find their vertex and then they will use the step pattern to plot the other points on their graph. So we always go over 1 unit and then up 1, over 1 unit, up 3, over 1 unit, up 5. And this works when our A value is 1, which we're going to explore in our equations. The same thing happens if you go in the opposite direction as well. So over 1, up 1, over 1, up 3, over 1, up 5. So that's something else that's really cool about parabolas. Let's do a few more examples so that you can get a better sense of how this works. All right, so first thing I want to do is I want to identify my y-intercept. So my y-intercept is right there. That's my y-intercept. So it has a point of 0 and -8. So I'm going to go ahead and plot that point on my Cartesian plane. Then I'm going to factor this in order to find my x-intercepts. So y equals x squared plus 2x minus 8. So I'm looking for two numbers that will multiply to give me -8, but add to give me +2. And if you're confident with your multiplication tables, you know that 4 times 2 is 8. One of those has to be positive and one of those has to be negative. So if I have +4 and -2, 4 take away 2 is 2. And 4 times -2 is -8. So those works. So then my x-intercepts, I have 1. So I'm just going to, a nice quick easy way is for your x-intercepts, we're going to switch the signs. So I have one x-intercept at -4 and 0, and I have another one at +2 and 0. So once you've found it in factored form, you're going to switch the signs to get the coordinates of your x-intercepts. So I have one x-intercept at -4, 0, and one x-intercept at +2, 0. So now I'm going to take that information and I'm going to find out where my axis of symmetry is. So the axis of symmetry says that I need to take my values for my x-intercept, add them together, so -4 plus 2, and divide that by 2. So -4 plus 2 is -2, and -2 divided by 2 is -1. So my axis of symmetry goes through this line right here, which means my vertex also is on this line. So how do I find my vertex? Well, I find my vertex by taking this -1 and substituting it into my original equation. And then I'm going to solve for y using order of operations. -1 squared is +1. 2 times -1 is -2. Take away 8. So I have 1 minus 2, which is -1. And -1 take away 8 is -9, which means I have a vertex at the coordinate -1, -9. So -1, -9, there is my vertex. So I have my x-intercepts, I have my y-intercept, I have my vertex. My parabola is going to open up because my x squared value is a positive number, so I can take that information and I can sketch my graph. So there is my parabola. So it goes through all of those points that I just graphed. Okay. Let's do one more example. Find your y-intercept first. My y-intercept is right here at the point 0, 1. So it crosses my y-axis at 1. Then I have to factor this trinomial in order to find my x-intercepts. So I'm looking for two numbers that will multiply to give me 1, but add to give me 2. The only numbers that multiply to give me 1 are 1 and 1. So I have y equals x plus 1 and x plus 1. So I have 1 plus 1 gives me 2, and 1 times 1 gives me 1. Now remember, if I have two brackets that are exactly the same, I could write it like this, which is x plus 1 squared. Okay, so keep that in mind. So what does that mean? Well, that means I have 1, 0. So if both of my brackets are going to be exactly the same, then I have 1, 0, because when I write my x-intercept, my one x-intercept is going to be at -1, 0, but so is my other one, and these are the same points. So I have -1 and 0 as my x-intercept. And when your x-intercept happens to be the same point, then this means that you're going to see later on, but you're going to see something really cool about that. I'm not going to tell you right away. Let's figure this out, the rest of it out. All right, so what is my axis of symmetry? Well, my axis of symmetry says that I needed to add my zeros together and divide them by 2. So let's go ahead and do that. So I had 1, 0 at -1. I had my other 0 at -1, and I'm going to divide those by 2. -1 take away 1 is -2, divided by 2 is -1. So my axis of symmetry goes right through my x-intercept. So when they are the same point, when you have only one x-intercept, your x-intercept, your axis of symmetry will go right through the x-intercept. Interesting. All right, let's take a look and see what happens when we try to look for our vertex. So the vertex says that we need to substitute my value of my axis of symmetry into my equation and solve for y. So y is equal to -1 squared plus 2 times -1 plus 1. -1 squared is 1. 2 times -1 is -2 plus 1. 1 take away 2 is -1. And -1 plus 1 is 0. So that means we have a vertex at the point -1, 0, which, look at that, is the same as our x-intercept. So when you have one x-intercept, that is the same as your vertex. So that's really cool to know. So this vertex is the same as our x-intercept, which is the same as our x-intercepts or our zeros. So we only have 2 points. So how do we plot another point? Where this is where we need to think about our reflection points, right? So if I have a y-intercept at +1, then equal distance away from the axis of symmetry is going to be your other point. And so now we have enough points to draw or sketch our quadratic relation. So I'm going to just go ahead and sketch this in here. That was really terrible. I didn't want it to be so big. Okay, I'll try to use a different color. There we go. So there's my parabola. If you have any questions about this lesson, please reach out to me. I know that this can be tricky, so send me an email, sign up for a virtual help session, send me a message on Teams, let me know how I can help you, and I will see you in the next lesson.